Assalamualaikum and a very good morning to our lecturer Dr. Yum Suhailah Yusof. My name is Nur Afifah Zahida and today my team and I are honoured to be representing our group assignment project, which is a report on practical tests for optimization and operation research. This is the member of our team. The first one is Maisha Sofia as the team leader, followed by Alia Norisa and Nur Ain Shuhada as shown on the first row. Next, on the second row, we have Anis Adrina Jane, and the last one is me, Nur Afifah Zahida. Steve Jobs stated that management is about persuading people to do things they do not want to do, while leadership is about inspiring people to do things they never thought they could do. So without further ado, let us jump into the main part of our presentation.
So hi, me and Maisha would like to present for the question 1. As in the slide, this is the question 1 that we obtained from the assignment instruction. Question 1 involved with the 6 alternative investment, which is A, B, C, D, E and F. And question 1 involved with the maximization problem. So the decision variables, we have 6 variables, which is X1 is represented as the number of amount to be invested in alternative A, and X2 is number of amount to be invested in alternative B, and so on. Okay, for the LP model, the objective for this question is the total return per share. As stated in the question, the total return per share is purchase price minus with the current price plus dividend per share, and this is similar with the current price multiplied with the projected annual growth and plus with the dividend per share. And using the value from the question, we obtain the objective equation as in the slide, which is max z is equal to 10.4x1 plus 11.5x2 and so on. Okay, so for the constraint, this is the constraints from the question, and after we simplify the constraint, we get the list this list of the constraint equation. And for this question 1, we have 12 constraints. And for this question, we use Lingo as to obtain the result, and this is the Lingo command. And the next one is, this is the Lingo solution. Okay, so for the next one is the discussion of the results. Okay, from the Lingo solution, we could get the optimal solution for the question 1. Okay, so for the question 1 is the optimum and or maximum requirement of total return of the investment is equal to 366,791 ringgit 25 cent, and the total infeasibilities of this question is equal to 0, which means no variables or no constraint is violated. Okay, so the next one is the optimal numbers of share to be purchased in each variables, which is the first one is alternative A. The optimal number of shares to be purchased in alternative A is 300 shares, and alternative B is 100 shares. Alternative C is 11,262.5 shares, and in alternative D 1,525 shares, and alternative E 100 shares, and the last one is the optimal numbers of shares to be purchased in alternative F is 1,250 shares. And for the slack or surplus, the slack is when the value of the equation is less than or equal to the constraint, and this means the slack is the unused number of resources. The next one is the surplus. The surplus is when the value of the equation is greater than or equal to the constraint, and this means the surplus is the exceeds amount from the minimum limit set by the constraint. And when the slack or surplus is equal to 0, this means the resources are fully used and the constraint is exactly satisfied as an equality. So for this question, the constraint 1, 2, 4, 6, 9 and 11 is have a 0 surplus, which means the resources in these constraints are fully used and this constraint is exactly satisfied as an equality. And for the constraint 3, it has 250,000 of surplus, which means this constraint is not satisfied as an equality, and it has 250,000 exceed amount of resources in this constraint. And for the constraint 5, it has 2,900 surplus, which means also the constraint is not satisfied as an equality, and it has 2,900 of exceed amount in this constraint. So for the constraint 7, it has 11,162.5 surplus, and constraint 8 has 1,425 surplus, and constraint 10 1,150 surplus, and the last one is the constraint 12. It has 95,876.25 surplus. So this means all the constraints that have a value of surplus means the constraint has not satisfied as an equality.
Now, we move to the dual price. As you can see here, this is the dual price value that we get from Lingo. So what is dual price and how does it work? The dual price of a given constraint can be interpreted as the rate of improvement in the optimal objective function value, where the right-hand side of the constraint increases with all other data held fixed. If the right-hand side of a constraint is changed, the dual price is the rate at which the objective value is impaired. So the value here, 0.1461, the dual price of constraint 1 means adding one more unit on the right hand side of the constraint 1 will cause the objective value here increase by 0.1461 to a total return of 366791. The dual price of 0.006967 of the constraint 2 here means adding one more unit on the right hand side of the constraint 2 here would cause objective value to increase by 0.006917 to a total value of 366791.94. And as you can see here, there is negative dual price. So the dual price of negative 0.1896 here of constraint 4 means increasing one unit on the right hand side of constraint 4 here will cause the objective value here to decrease by 0.1869 to a total return of 366791.0604. It's the same with the constraint 6 and constraint 9 and constraint 11 with just a different value of dual price. So, as you can see on the screen, the constraint 3, 5, 7, 8, 10 and 12 have zero dual price here. So does an increase of 1 in the right hand side of this constraint will change the optimal value? The answer is no. Since the dual price is 0, the optimal value will not change. Thus, increase the right hand side of the constraint with 0 value of dual price is pointless. For the change of the right hand side of the constraint, the interpretation of the dual price mentioned earlier is only valid within a range of the given right hand side. The dual price may change to a different value outside this allowable range. This allowable range mentioned can be seen on the screen right now, which was obtained by Lingo. Given the situation, we can say that the price worth for adding 1 unit of share and reduce cost will remain constant as long as the right hand side of constraint fall within this range. The objective coefficient of x4 must decrease within 2.275 here and increase 1.775 within this range. For x5, it need to be equal or less than 20.89375. For objective coefficient x6, it can increase infinitely or decrease within the value 1.3833. If all of the 6 objective function here, x1, x2, x3, x4, f5, and x6, stay in their respective range here, then the optimal value will not change. Now, we go through few of the constraint one by one. So, if the maximum total amount invested, which is the right hand side of constraint 1 here, decrease within the value of 2034059.7 and increase within double of its current value, then the dual price and reduced cost will remain constant. This is similarly implied to the constraint number 2, where the dual price and reduced cost will remain constant if the maximum amount invested in F, which is the right hand side of constraint 2 here, stay within the range of 20,000 and 1,738,333 and 3. If the maximum amount invested in A and B combined here, if they stay either equal or greater to 250,000, the dual price and reduced cost also will remain constant. And this also applied to all the constraint here, from constraint 1 into the constraint 12, where if they still into the allowable range, then the door price and the reduced cost will remain constant. So now we move to the objective function. So by satisfying the 12th constraint earlier, the optimal return for the investment that we get is 366,791.25 here. The optimal value will not change as long as the objective coefficient here increase or decrease or fall within the range. So we can see here, if the objective coefficient of x1 decrease within 0.896667 and increase within 0.5916667, then the optimal basis does not change. As you can see here, this is the table for the range for the objective coefficient must stay to make sure the optimal basis does not change. Thus, all of the variable must stay between this range to make sure that the optimal basis does not change. So for x2, the objective coefficient must equal or less than 12.62. For the x3, the objective coefficient x3 must fall within the range 22.71 and 24.42. That's all for number 1.
Next, we will discuss about question 2. This question requires us to determine the minimum number of nurses, and we have to solve the problem by using LPP. These are the first part, which we provide all the decision variables that we understand and take it from the questions. We denote that xi is equal to the number of nurses that begin the 8 hours working period I, where I is equal to 1, 2, 3 until 12, while the period starting from 00 hours to 24 hours. After that, we came out an LP model, which is stated as minimum Z is equal to x1 plus x2 plus x3 until plus x12 and subject to those equations.
Hi, next I will present how to solve this equation using lingo. So this is our lingo command that will be solved. So here the lingo result. Here we can see that the Z is 170. It shows the optimum and the minimum numbers of nurses that will work through the day. So the other variable is x1, x2, x4, x6, x7, x5 and x9. For x1 we got 30. For x2, x4, x6 and x7 we got 10. For x5 and x9 we got 50. The number shown that this is the optimum and the minimum number and the number of nurses that will start their shift in each of period 1, 2, 4, 6, 7, 5 and 9. And for the others shift, there are no nurses that start at their shift. So next we will go to select and surplus. What is select and surplus? It represents how close it is to satisfy a constraint as an equation. Select comes in less than and equal equation, while surplus comes in greater than and equal equation. So since this equation, all of the constraint is greater than and equal equation, so we have two surplus. Both constraint 2 and constraint 5 give a surplus of 10. It means that both constraints exceed a minimum number limit of nurses with 10. Next, we will discuss about door price. Door price is about a unit worth of the constraint. So for this question, we got three constraints with door price of -1, which is constraint 3, 7 and 11. From constraint 3 is a time period between 4 a.m. to 6 a.m. while 7 is from 12 p.m. to 2 p.m. and 11 from 8 p.m. to 10 p.m. So for this constraint, if you add one more nurse, it will improve the minimum numbers of nurses by 1 to a value of 171 nurses in the objective function, which we do not want the number of nurses to exceed the minimum requirement that we get from the Z value.
Most LP programs will optionally supplement the solution report with a range or sensitivity analysis report. To get the sensitivity analysis report, click Solver and then click the Range button. And we will get sensitivity report, which is objective coefficient range and right-hand side range. Again, we find two sections. The first one is for variables and the second for row or constraint. In general, if the objective function coefficient of a single variable is changed within the range specified, then the optimal values of the decision variable x1 to x12 in this case will not change. For example, for the variable s1, the current coefficient allowable to decrease by 1, which is 0 or remain with 1, to keep the optimal value unchanged. Next, for the variable x2, the current coefficient can increase up to infinity. Likewise with the variable x10, x11 and x12. Next, in a complementary sense, if the right-hand side of a single constraint is changed within the range specified, then the optimal values of the demand number of nests will not change. For example, from the RHS table, current RHS for row 2 is 30. It is not allowable to increase, but allowable decrease to infinity. So the demand for nurses during 12 midnight to 2 am must be less than or equal to 30 to keep the optimal value. Next example, row 4, demand for nurses during 4 am to 6 am must be greater than or equal to 40.